Let's consider phases of matter. We have gas, liquid, and solid. These phases are determined by the magnitude of the intermolecular forces present. So, as an example, consider the nitrogen molecule. Two nitrogen atoms bonded together. There is no dipole. So, the only possible forces between two nitrogen atoms are instantaneous dipole, which are dispersion forces. And nitrogens are fairly small molecules, so it's hard to distort their electron cloud, so the dispersion forces are weak. And therefore, there's not much holding together nitrogen molecules, and therefore nitrogen is a gas at room temperature. Now let's consider iodine. Iodine is also a diatomic molecule. It has no dipole moment, and so it only has dispersion forces. However, iodine is a rather large atom, and so it has a lot of electrons, and its electron cloud is more easily distorted than, say, nitrogen, and so the dispersion forces are strong in comparison. And iodine is a solid at room temperature because of the greater magnitude of the intermolecular dispersion forces holding the iodine atoms or iodine molecules together. Another example is water. Water has a dipole moment, but also has strong hydrogen bonds. And so these strong hydrogen bonds, pursuant to its dipole moment, that make water a liquid at room temperature. It's a liquid at room temp. Another interesting progression is to look at hydrocarbons. Say we start with natural gas, methane. One carbon, we move to ethane. 2 carbons. I'll draw this. CH3s bonded together. Then we move to propane. 3 carbons. We move to butane. 4 carbons. We'll go to pentane, which is 5 carbons. Now let's look at the boiling points. The boiling points of each of these. Okay, for methane, which is natural gas, the boiling point is negative 161 degrees centigrade. For ethane, it's negative 88. For propane, it's negative 42. For butane, it's negative 0.5. And for pentane, boiling point is 36.1 degrees centigrade. So what we see from here is this progression. As the molecule gets larger number of atoms, the boiling point goes up. For these hydrocarbons, Once we go from butane here to pentane here, we become a liquid at room temperature. So all four of these molecules are gases at room temperature, but pentane is a liquid at room temperature. And you can see the increasing boiling points, and that is due to the increase in dispersion forces of these molecules. So the intermolecular forces increase, and so the interaction force between molecules increases, which increases their boiling points. And finally, a phase change occurs between butane here with 4 carbons and pentane here with 5 carbons. So the magnitude of the intermolecular forces determine the phase at room temperature and 1 atmosphere pressure. Standard state, 1 atmosphere pressure and room temperature.